Hey students, I thought I'd make a quick kind of a trig review, or it's really more of a right angle trig review, and because it's just the trig that you really need for this class, and maybe some helpful hints too here. So let me just start with the math that might be less familiar to some of you. I was talking with the math department and looking at your sequence of mathematical classes to get here, and your trig is kind of spread out in between, and there's some right angle trig, but don't really have a formal class on it. So anyways, let's just talk. First of all, let's just make a right triangle, and that's what we mean by right angle trig, and that's what we're going to look at is triangles that have a right angle in it. And if I label the two legs A and B and the hypotenuse C, and give that some angle, call it theta, and for that matter, this angle here, maybe I will call alpha. But these trig functions, there are three of them, and that's what you really need to know to understand, is that there's one trig function called a cosine, another trig function called a sine, and another trig function called a tangent. And so if we take it in terms of theta, we get what? And it also might be nice to compare that same trig function, so cosine, sine, and tangent, with maybe the other angle in the triangle. I wrote it vertically, so maybe I'll call that gamma. Gamma, I think I said alpha, but my Greek letters aren't very clear. So gamma, okay? And the basic idea of cosine is that you take the adjacent leg over the hypotenuse. So over hypotenuse. But the adjacent leg to theta is B, and the adjacent leg to gamma is A. And so one thing you need to be careful about is to make sure that when you are doing a cosine function, you think of it as adjacent over hypotenuse. Because notice, when I'm looking at this angle, the adjacent is B, but when I'm looking at this angle, the adjacent is A. And that can throw students confusion. It's like, well, wait, I thought the numerator was always, say, the x-axis, which would be B, and then all of a sudden you're using A. And, well, that's true, it's the x-axis when you use an angle from the x-axis, because we do adjacent, and then it's A, or the vertical component, the y-axis, when we do a vertical angle, because, again, it's adjacent to that. So it's not just automatically an x, it's the adjacent piece. And so you got to pay close attention to which angle you're looking at. Now, the sine function is kind of the same idea. It's over the hypotenuse, no matter what angle you're looking at. But it is then the opposite. So the opposite in this case would be A, and then the opposite of gamma would be B. So again, same warning here. You use the sine function when you want the opposite piece. And the opposite piece could be, like in this case, the opposite piece would be the vertical component. But in the gamma case, the opposite component is the horizontal. So again, sine doesn't always give you the vertical piece. It always gives you the opposite. Depends what angle you're looking at. And most people are familiar first with trig functions that are measured from the x-axis like this. But in a physics problem, we can't always be choosy of what angle we have. So sometimes we look at it in terms of the y-axis. And so we have to be careful with that. You might also notice that complementary angles, the sine and cosine function, are the same thing. But perhaps I'm getting too advanced for this little review here. I just want you to really see adjacent over hypotenuse, opposite over hypotenuse, and then the tangent function. Oh, oops, I didn't leave myself enough space here. Whoops, I shouldn't have made that circle. But the tangent is the opposite over the adjacent. And so when you look at the gamma one, opposite is B, and adjacent is A. So again, got to be careful what angle you're looking at. But let me focus our attention here really on kind of the standard angle, which is from the x-axis. And what this is really kind of saying mathematically here is if you know any two of the triangle, then you can get the angle. And so I want to show you how you get that angle. Because if I knew the B and the C, I can get the angle. If I knew the A and the C, I can get the angle. If I knew the A and the B, I can get the angle. And in fact, what started this review was me doing a problem, part D on a hard one, which was asking for the angle. And I used the trig function and commented that you could do either one of them. Because at that point, we had started off knowing the legs of the triangle, A and the B. But then we also did Pythagorean's theorem, which gave us the third side. So technically, you could say that I could use any of these trig functions once I know two of the sides. Because if I know any two, then I could use the Pythagorean's theorem to get the third. And now when I know three, I can use any one of these to get the angle. And that's kind of how we did that problem. But it's this connection that I wanted you to see. Now, if I just gave you some numbers, let's do, say, the magical triangle. And so if A is 3 and B is 4, that makes C 5, because 3 squared plus 4 squared is 20. Well, 3 squared is 9, 4 squared is 16. You add them together, that's 25. And so C is 25 squared, so you take the square root and you get a 5. So that's one of the magical triangles, the 3, 4, 5 right triangle. And to get that angle, say theta, I would go cosine theta, and it would be the adjacent, which is 4, over the hypotenuse, which is 5. And 4 divided by 5 is 0.8. And then to get the angle, you undo the cosine function. So this is called the arc cosine function. So I need to do that to both sides. And the whole point is by doing the inverse operator to the cosine, you're left with just the angle theta. That's what I'm trying to find. And for our case, we don't have to do any of these by hand. We'll just use the calculator. So if I go inverse cosine function, technically called arc cosine function, of 0.8, then when I hit enter, I get the 36.9 degrees. Which, of course, means this other angle would be 90 minus that. And so the gamma angle would be 53.1. Of course, let me show you that I could have, and I guess I scribbled it out, but I could have gone cosine of gamma. Cosine of gamma is the opposite. See, the 4 over the 5, which is the 0.8, which is the same math we just did here. Oh, I'm sorry. I said that wrong. That's not what I meant to say. Gamma here would be the adjacent, so that would be the 3. There we go. The 3 over the 5. And doing the same math, but I have a different number, 0.6, I would have then the inverse cosine of 0.6. And I should get that 53. Let's try it on the calculator. Inverse cosine of what would I say, 6. Yeah, and there it is, 53.1 degrees. So I could get any of those angles. Now, there's a lot I could do here, but I think for a quick review, I should probably keep it simple. And I showed you the cosine function, but of course, the sine function would work the same way, and so would the tangent. And so again, just to say I was trying to find this angle theta, the sine function would be the opposite. That's the 3 over the 5, so opposite over the hypotenuse. And the tangent function would be the opposite, 3 over the adjacent 4. And therefore, to get this angle, I have to do the inverse function of the sine. So this side of the equation would be labeled as inverse sine of sine theta, and that would undo each other and get theta. So over here, I would have inverse sine of 0.6. So let's see what I get, and hopefully I get that same angle of 36.9. And likewise for tangent, I could go inverse tangent or arctangent of theta, which means I get my theta. And that means I would be doing on the other side the inverse or arctangent of 0.75, since 3 over 4 is 0.75. And again, hopefully I'd get that same angle. So again, it wouldn't matter which of the two I knew. So let me try this. Inverse sine, so it'll be this button here in the blue, inverse sine of 0.6. Hit enter, and sure enough, I get 36.9. And then over here, let me go inverse tangent of 0.75, and that would be 36.9 also. So that's what I wanted to show you in this review, that you can use any of your 3 trig functions. You use them here on your calculator. These are the inverse of them. And you can get then the angle once you know any 2. As well as you can use Pythagorean theorem and get the third. And that's probably the hardest. Maybe I should, before I wrap it up, show you kind of the other direction. You know, for example, let's say we knew that this angle was already the 36.9, and we knew the hypotenuse was 5, but we did not know that side or that side. So we've got 2 unknowns in our triangle, which is why by itself we can't use Pythagorean theorem. We got the 2 unknowns, but again, coming back to our trig functions, we can use this to get the other sides. So I could use then either the cosine or the sine, depending if I'm trying to get the adjacent leg or the opposite leg. See, watch. If I did cosine of 36.9, I would do adjacent b over hypotenuse of 5. Or, if I wanted the vertical component, I would go sine of 36.9. And that would equal opposite, which is that unknown a, over the hypotenuse 5. And had I given you, say, b instead of the hypotenuse and you wanted a, I would do a trig function, because then I would know b and I know the angle and I can get a. So these 3 trig functions are really nice, because it means that if you know one of the legs of the triangle and one of the angles, you can get the rest of the pieces. And so in this case, I guess I'd move the 5 to the other side. So I'd have 5 cosine of 36.9 is equal to my b. And then same thing here, I'd have 5 sine of 36.9 is then equal to the a. And this one you're probably more familiar with, so that's why at first I wasn't going to do it. I was just going to show you the inverse operations. That's the hard one. But this we're going to do a lot moving forward. We're going to give like the magnitude. We're going to say like you throw the ball at some speed, 5 meters per second at an angle of 36.9. And then in order to solve the problem, we need to know how much of that speed is vertical, so what is A, and how much of that speed is horizontal. And so we do a lot of this. And so giving it a try here, I'll just go 5 times, and I'll go cosine 36.9. Oops. I must have... Oh, Sorry, bad typo there. Let's try it again. That 5 times cosine of 36 points. Oh, I see. I hit the negative there. 9. And so this rounds to a 4. Good. And then same thing here. 5 times, and we'll just do the sine. Not the inverse sign, but the sine. And we'll go 36.9. And then that should be the 3. Yep, 3. And so I can get the other 2 sides. Of course, to be quite honest, I could also, once I got one of the sides, like the B, then come up here and use the Pythagorean theorem to get the A. So I have a lot of options. And of course, I could do the other trig functions once I know an angle too. So, all right. Well, I'll stop there, but keep in mind, there's a mathematical connection between one of the angles and the sides. So, if you know any 2 of these 3, so if you know an angle and one side, you can get the other side, which then you can get everything else. If you know 2 sides, again, you can use Pythagorean theorem to get the 3rd side, and you can use the trig functions to get the angle, and then you can get the other angle. So, yeah, that's it. So any 2, so both sides get an angle, or one of the sides and an angle, get the other side, and then you can get all the other pieces. That's the advantage of these right angle trig. And that's as much as you'll need for this class. All right. Hope that helps someone. Take care.